Have you ever truly wondered what it would feel like to stand upon another world? It is a question that sparks the imagination, taking us on a journey far beyond our familiar blue home. We often see breathtaking images of distant planets, but to genuinely comprehend them, we must consider the fundamental forces at play. Today we will embark on a simple, guided tour of our solar system, not through a telescope, but through the sensation of weight. We will explore the pull of gravity on each of the 8 planets, comparing it directly to what we experience every day right here on Earth. This is a journey anyone can understand. This exploration will be structured in a clear and easy-to-follow manner. We will travel from the planets with the lightest gravitational pull to the one with the most crushing weight. Let us begin this gravity showdown and feel the universe in a new way. Our journey begins with the planet closest to the Sun, Mercury. This small, rocky world is the featherweight champion. Its surface gravity is only about 0.38 times that of Earth. To put that into perspective, if you weigh 70 kilograms on our home planet, you would feel as if you weighed a mere 27 kilograms on Mercury. Every step would feel effortless. A simple jump could send you soaring to incredible heights. A world of exhilarating lightness and newfound freedom. Next on our list is the famous red planet, Mars. Interestingly, despite being significantly larger than Mercury, its surface gravity is almost identical, about 0.38 times Earth's. So that same 70-kilogram person again feels like 27 kilograms. Imagine the possibilities for exploration. Carrying heavy life support equipment would be easier. Geological tools would be easier. Building materials for a habitat would be easier. This reduced gravity makes Mars a slightly more manageable destination for future human missions, despite its many other challenges. This low gravity has profoundly shaped the Martian landscape. The planet is home to Olympus Mons, the largest volcano in the solar system. It towers nearly 3 times the height of Mount Everest, a scale impossible to sustain on Earth. Our stronger gravity would collapse it. A perfect example of how gravity shapes geology. The Martian sky offers a unique spectacle. Fine red dust in the thin atmosphere makes daytime skies pale pinkish orange. So, on both Mercury and Mars, you'd feel remarkable lightness. You could bound across cratered, dusty surfaces with ease, feeling nimble and powerful. However, this lightness comes with a trade-off. Their weak gravity can't hold a thick, protective atmosphere like Earth's. Mercury has almost no air and faces extreme temperatures. Mars has a wispy, far too thin atmosphere for breathing. These first 2 stops show that, while low gravity sounds fun, it creates profoundly alien environments. Continuing our countdown, we arrive at a world often called Earth's twin due to its similar size and mass, Venus. Here, the gravitational pull is remarkably close to our own, measuring about 0.9 times that of Earth. For our 70-kilogram traveler, this would translate to feeling as if they weighed 63 kilograms. The difference would be subtle, perhaps like the feeling of having lost a bit of weight. You would walk and move in a way that feels almost normal, a comforting familiarity after the bounciness of Mars and Mercury. Your body would not have to strain or adapt significantly to the pull of the planet. Next, we journey to the outer solar system to visit the ice giant Uranus. Despite being vastly larger than Earth, more than 4 times our planet's diameter, its surface gravity is surprisingly gentle. Because it is a gas giant with a very low density, the surface, where atmospheric pressure matches Earth's at sea level, has a gravity of about 0.89 times that of Earth. This means our 70-kilogram person would feel even lighter than on Venus, weighing in at about 62 kilograms. It is a strange thought, standing on a world 14 times more massive than Earth, yet feeling slightly lighter. Of course, our standard of measurement is Earth itself, where gravity is the constant we live by, which we define as 1g. Here our 70-kilogram person weighs exactly 70 kilograms. This specific gravitational pull has been the cradle for all life as we know it. It is strong enough to hold our precious oceans and our breathable atmosphere to the surface, preventing them from escaping into space. It has shaped our biology, from the strength of our bones and muscles to the way our cardiovascular systems pump blood. Earth's gravity is, for us, the perfect balance. Not too strong, not too weak, but just right for life to flourish. These three planets, Venus, Uranus, and Earth, occupy a sort of familiar zone in our gravity showdown. On any of them, your weight would feel broadly similar, within about 10% of what you are used to. Yet this similarity in gravity masks wildly different worlds. Venus is a scorching hellscape, with a crushing atmosphere of carbon dioxide and sulfuric acid rain. Now, we enter the realm of the giants, beginning with the jewel of the solar system, Saturn. This magnificent gas giant is immense, with a mass 95 times that of Earth. Yet, if you could stand on its cloud tops, you would be surprised to find that the gravitational pull is only slightly stronger than what you're used to. At about 1.06 times Earth's gravity, our 70-kilogram person would feel they weigh around 74 kilograms. This is because Saturn's incredible mass is spread out over an enormous volume. It is the least dense planet in our solar system, so less dense in fact, that it would float in a giant bathtub of water. The iconic rings of Saturn, while visually spectacular, would have no bearing on the gravity you would feel at the cloud tops. These rings are made of countless small particles of ice rock, orbiting the planet far out in space, and their collective mass is negligible compared to the planet itself. The true wonder of Saturn is its gaseous nature. There is no solid surface to stand on. Instead, you would sink into deeper and deeper layers of hydrogen-helium, where the pressure and temperature would quickly become unimaginably intense. Finally, we arrive at the undisputed king of our solar system, Jupiter. This colossal planet is a true heavyweight in every sense. Its mass is more than twice that of all the other planets combined, and its gravitational pull is immense. At the cloud tops, the gravity is a staggering 2.53 times that of Earth. Our 70-kilogram person would feel as if they weighed an almost unbearable 177 kilograms. Every movement would be a struggle. Simply lifting a foot would feel like lifting a heavy weight, and trying to stand up from a seated position would be a monumental effort. You would feel utterly pinned down by the planet's power. This incredible gravitational force is what makes Jupiter the great guardian of the inner solar system. Its immense pull acts like a cosmic vacuum cleaner, attracting and capturing stray comets and asteroids that might otherwise pose a threat to planets like Earth. Our brief journey through the solar system reveals a clear and fascinating pattern. The small, rocky world of Mercury exerts a gentle pull. Mars exerts a gentle pull. The colossal gas giant, Jupiter, commands a much more powerful gravitational force. In between, we find a comfortable middle ground, Venus, Uranus, Earth, where weight feels strangely familiar. This simple comparison gives us a tangible connection. Feather-light bounciness of Mars, crushing heaviness of Jupiter. The reason is elegantly simple: mass and size. More mass means stronger gravitational pull. Density matters too. Saturn is massive but spread out, so surface gravity is mild. Earth is smaller but dense and rocky, so its gravity is respectable. Picture yourself standing on its surface. On Mercury, you could leap over craters. On Jupiter, you would struggle to lift your arm. On Venus, the air would be toxic and the heat unbearable, but your weight would feel almost like home. Gravity does more than determine jump height. It dictates the potential for a world to host life. This thought experiment reminds us we're part of a vast cosmic family. Each world, a story of planetary evolution. Thank you for joining me on this tour of gravity's domain.